AV Shop Talk, Episode 17.
Podcasting from Boston, Massachusetts and Los Angeles, California, this is AV Shop Talk. Covering the latest audiovisual trends and emerging technologies, this is where the AV pros come to talk shop. With your hosts, Nate Schneider and Jason Griffin.
Hello there and welcome to another episode of AV Shop Talk. Jason Griffin here. So happy to be with you, joined again by my partner, Nate. Nate, how are you?
I'm doing just fine on this lovely Wednesday evening. Well, we are recording on a Wednesday evening, but you won't be listening necessarily on a Wednesday evening.
That's right. In fact, you will be listening on our new publish date, which this is something that we wanted to mention. Since we started, really, we've been doing a monthly show, and we try to get an episode out every month. And we just have decided recently to switch that to the first. So the first of the month, we think it's kind of easier for people to remember. I know we've got a number of people now who tune in regularly to the show. We really appreciate it, and we just thought, kind of makes sense to do it on the first, and it makes it a little bit easier for people to kind of put that on their schedule and remember, hey, it's the first of the month. We got a new episode of AV Shop Talk out. So that this is going to be our second episode doing that.
Yeah, I think it makes sense. And before we were kind of semi-regularly publishing on the 25th, and we just kind of arbitrarily picked that day as we started forming the podcast and getting into a good routine here and making sure it was a sustainable product that we could crank out this content once a month. And like Jason said, the first just seems to make sense. So the first of the month, you got a brand new episode of AV Shop Talk to listen to.
Yeah, you got it. And speaking of that, like I said, the first episode that we decided to do that for was actually our last episode, where we had Bill Scripsima on from Adlona. And we really enjoyed that conversation, and it just kind of got us thinking about HDMI. I mean, I feel like HDMI is a topic that is always on our minds as integrators, and I think most people listening can relate to that and would probably agree with it to a certain extent. But doing that show with Bill really kind of got the wheels turning, right, about HDMI and HDMI 2.0 and HDCP 2.2, and there's just a lot going on with it right now. It's very much an evolving landscape. Even more so than it always is, kind of. And with that in mind, we've just sort of been keeping a closer eye on it, and that kind of led us into doing this episode, right, where we were sort of wanting to dive into HDR, which is kind of part of this evolving video landscape, and we look forward to kind of sharing some of our thoughts on that in this episode. Yeah,
it was just before we recorded that episode with Bill. HDMI sent out a press release. And this press release came out on April 8th, 2015, and it was from it's titled HDMI Forum Inc. Releases 2.0 version A specification, and that enables transmission of high dynamic range HDR formats. So that came out April 8th, and this really got my wheels turning in my head a little bit, because there's not a whole lot here in the press release, but I had always known HDR to be, something from the photography, the still photography world, with tone mapping and taking pictures at multiple exposures or f-stops, up and down the spectrum, and then kind of meshing them together and blending them together with some, human intervention. I've never seen, a program that would automatically actually, I should take that back. There are programs that automatically do some of this tone mapping, but it does take a trained eye and a skilled photographer to kind of make them look good. I've seen a lot of bad HDR still photography out there, but to make one that really, really stands out, it takes a lot of skill to do. So that's kind of where I was coming from with HDR. And then I saw this specification or this press release, and this is just a quote from the press release. It says, we recognize that HDR would be a critical feature as the industry evolves. Our support of HDR enables 800 plus HDMI 2.0 adopters to develop market-leading products that include HDR and will maintain interoperability across the entire HDMI ecosystem. So, HDMI is picking up on this trend, but there's somebody that we got for this interview who you'll hear very soon, who's been working on HDR video for the last 6 years.
Mm-hmm.
So it was just a natural progression to kind of invite Alan onto the podcast, and we're really excited to be able to get a little bit of his time and pick his brain about HDR.
Yeah, and his name's Alan Chalmers, and we'll tell you a little bit more about him kind of right before we dive into the interview. But yeah, I agree with what you're saying, Nate. I mean, HDR is one of these topics that I know on the residential side of the business I can speak to personally. It seems to be gaining a lot of traction. It's got people's attention. Obviously, 4K and UHD are really what most people are talking about, and most consumers and end users are really kind of have their eyes focused on. But like HDR, from the general consensus to me seems to be that this is a big deal, and it really is like something that makes a substantial difference in the picture quality. And arguably, there's a lot of people who kind of talk about 4K and does it really matter, especially when you get into smaller TVs. And the thing about HDR is that it doesn't matter what size your TV is. It in theory at least can make a dramatic improvement to the picture quality. And there's a lot to it, with the technology kind of evolving from something that originated as a photography method and now moving into video, which obviously is a whole different ball of wax. And I just was really curious to learn more about it. How is this content being produced? How is it being, handled in post-production? How is it being delivered to, consumers? What are the bandwidth requirements? All of these sort of questions that come into play when you really start to dive into a new specification like this in market adoption phase like we're in. And I really enjoyed our conversation with Alan. I took a lot away from it. Yeah,
and that's the other thing too. It's like everything. This is so early in the game for HDR video. Everything is up in the air right now. I mean, there's no hard and fast standard that everybody can just adopt quite yet. I mean, that's still in the works. Down to image capture. On the at the camera level. And encoding, how this signal is actually encoded and how it's transmitted, and then how it's reproduced at the display. All these things are still up in the air, and I think the only thing I'm certain of is that it's going to require more bandwidth, and it's just how much more bandwidth will we be able to get. And so I think it's an important issue to keep your eye on. But we should probably jump on into the interview. You're about to hear me trip over my tongue a little bit here. This is what happens when we record early in the morning when we get a guest over on the other side of the world. But really, really enjoyed this chat with Alan Chalmers from goHDR. Hope you enjoy it too.
AV Shop Talk.
Welcome to the AV Shop Talk podcast. I'm very pleased to be introducing to our listeners Alan Chalmers, I should say. Actually, Professor Alan Chalmers, I should say. He is a professor of visualization. Man, I can't get my mouth to work this morning. Professor
needs to wake up. Yeah.
This is what happens when we record in the morning, right? Oh man, Professor of Visualization at the University of Warwick. Not only that, he is the Innovation Director at goHDR. So, Alan, thank you so much for joining us. How are you doing today?
Thank you for having me. Yes, well, it's nice afternoon here, so I'm awake here. So we'll see how we go.
Yeah. So it's almost 2 in the afternoon over there in the UK. So it's fun to be chatting with people around the world. It's just the power of the technology we have at our disposal here is mind blowing. So very excited to be chatting with Alan. Now, just recently at NAB 2015, Alan was involved with. He was actually a presenter for one of the engineering conferences. Where they were talking about all kinds of new and developing technologies. And obviously, Alan is an HDR guy. So we're going to be really getting into some of the nuts and bolts about HDR, why it matters for integrators. But before we get into all that, Alan, can you tell us a little bit of your story and basically how did you end up where you are now as the innovation director at goHDR?
Okay, good question. So I've been involved in high dynamic range for more than 15 years now. I was originally working on still images, a lot of work on tone mapping. Then I was involved in the advisory board for Brightside Industries, which effectively invented HDR displays. They were spun out from the University of British Columbia, led by a genius called Helga Zietzen. And got to the point where I realized that we had these wonderful images on these HDR displays, but they were static. And there was a need for video. And that was going to be the obvious next step, that when people saw the static images, they realized that they want them to be moving. And so that's basically how we got into it. Over 8 years ago, I got a big research grant to have the world's first HDR video camera made for us. It was made by a German company called Spheron. It could capture 20 f-stops at 30 frames a second at full HD resolution. Very expensive, but did the job and showed us that HDR video would make a huge step change in viewing experience. And that led us to realize that the amount of data generated by HDR video is enormous. I mean, to capture the full range of light in a scene, you need floating point numbers. So you're basically talking about 96 bits per pixel. So at full HD resolution, that's 24 megabytes, at 30 frames a second. A minute of footage is 42 gigabytes of data. So it's effectively a CD of data a second. And you really, so to cope with that, you need compression. And that led us to come up with a compression algorithm, which we then spun out the company goHDR to try and commercialize that. 6 years ago now, when no one really knew what HDR was, because everything was 3D. That's everyone was talking about was 3D. Now things have changed, and now HDR is the flavor of the month. And it's in some ways because 3D failed to make the impact that they were hoping.
Yeah, and I think that's an important distinction to make there between, because HDR in the photography world has been around for a number of years. I think at least 10 years or so. But when it comes to video, this is a whole new world. This is kind of uncharted territory. Well, at least for the last 6 years, it's been what you've been working on with goHDR. But there is definitely an important distinction to make there. But Jason, did you have a question you wanted to jump in with?
Yeah, no, I mean, I think that you make a good point, Nate and Alan both, that HDR has been around for a while, but with video, it's kind of a brave new world out there, and it's something that people are clearly excited about. A lot of my clients on the residential side of integration are asking about it, and I feel like, where 3D was a technology that was kind of being pushed on consumers, there seems to be a lot of demand for HDR, and people seem interested with it. And I definitely look forward to getting further into that discussion about HDR and what it is and what needs to happen for it to be effectively adopted. But Alan, before we get into that, I always think it's insightful to learn a little bit about like your company and where you guys kind of stand in this whole developing ecosystem. So speaking of goHDR, can you tell our audience a little about like who your clients are? What is your product? What are you guys selling, and who's buying it?
Okay, so goHDR is a spin out from the University of Warwick. So Warwick University is a major university in the UK. And they have a technology transfer office called Warwick Ventures, whose job is to try and commercialize some of the technology. Now, the UK is particularly bad at this. The US, of course, has been leading the world in this. People like universities like Stanford and MIT have formed some of the great companies in the world. And the UK has definitely been behind the curve, and so there's a lot more talk within the UK to try and get technology. We do great research over here. We publish lots of papers, but how do we get that to actually be used? And so it's one of the sort of the key challenges facing academics nowadays to do that. And so this was an idea to look into this. I must say, when we started 6 years ago, as I said, HDR was not even talked about. We speak to people and they got confused between HD and high definition. But now it's come down to the fact that 3D has failed because evolution incompatible. Your eyes are not designed to see 3D televisions. 40,000 years of evolution have not led to the point where you can watch 3D television comfortably. And so but they still want to sell you a new television, and they try to sell you a 4K television. More pixels, but unless you've got the house the size of a planet, or you're about 2 inches away from the screen, you can't really tell the difference. And so people looking at 4K and say, oh yeah, maybe, but so they want a wow factor. And the reason why HDR has suddenly come on to really exploded into everyone's psyche is because of the fact when you say HDR and low dynamic range, or what the broadcast industry calls standard dynamic range, side by side, there's no doubt that the HDR image is better because it's brighter, it's got more dynamic range. And that's really why HDR is suddenly popular, not because of any scientific progress, but simply because people want to sell you another television. So goHDR is a small company, and this is one of the difficulties we're facing because the big players are now getting involved, although we've been around for a lot longer, and they just push you, and they're trying to push their own brand of HDR because they're trying to make money and sell you a new television. And that's where one of the things I think the problems facing the whole technology is that people are going to adopt something just to sell you the television rather than to give you something which will really provide a step change in imaging. The same as it was when we went from black and white to color. The huge step change really made a significant difference. People could clearly see the difference, and it's exactly the same between low dynamic range and high dynamic range. Because a clear, obvious difference. But let's get it right.
Yeah, definitely. And you guys, to that end of trying to get it right, my understanding is you guys have developed a compression algorithm that's sort of your secret sauce, right? And that's what you're out on the market with. And people who are buying this are they television service providers? Are they hardware manufacturers? Who specifically are you guys targeting with your product?
So for now, I mean, the big problem with the industry is, as with anything, everyone's watching everyone else at the moment. So there are a few people who are starting to dabble with it, but most of our applications have been niche markets. So people who have an obvious need for HDR, such as, for example, security, where you can suddenly see the detail in the dark shadows and in the bright area simultaneously. You don't have to worry about where the camera is deployed to see the detail. We've done some work with the Kennedy Space Center looking at how do you look at rocket launches, which are extremely bright. How do you see detail in that? And then medical applications where you want to see, you're doing filming operation and you don't want to put extra lighting in there because it distracts the surgeon from the actual operation. But without the extra lights, a traditional camera can't see it. So we've literally put our camera over the shoulder of a surgeon, and we've seen from the deep, dark body cavity all the way into the bright areas without any extra lighting. So those sort of niche applications are obvious needs, but they're not the big market. The big markets, I think, is going to come from people who just want to shoot their friends on a bright, sunny day and not worry about the fact that the precious moments lost because they happen to be against the bright window when they're filming inside. So I think what we call everyday HDR, I think, is going to be the change when people start to realize they don't have to worry about lighting. They can just take the pictures and the video and see all the detail.
Yeah. Now, looking over your NAB presentation, I just looked at the summary, and I'm just going to read a little excerpt here. So this is a quote here. The standards bodies are currently investigating whether existing video coding standards are already able to support HDR, or whether changes are needed to meet this new requirement. So I guess my question about that is, who are the active stakeholders, when it comes to these standards bodies, and what criteria do you think that they're trying to use to determine how this new standard is written?
Well, all the standard bodies are looking at HDR. Any standard body at all involved in video and technology is looking at it. So you've got MPEG as the big one, of course. You've got SMPTE. You've got DVB, you've got the European Broadcasting Union, you've got a whole range of the Blu-ray discs. All the standard bodies realize that there's going to be the step change in imaging. It's going to involve HDR. It's all part of the UHD TV standard. So it's all part of the ultra high definition TV standard, which is the future of television, which of course contains 4 parts. One is the resolution, that's 4K or 8K. The second is high frame rate. The third is the wider color gamut, and the fourth is the high dynamic range. So everyone's looking towards that. Of those 4, they've tried 4K, and I say no wow factor. Wider color gamut, high frame rate, a little bit of a wow factor, but not as obvious as HDR, and that's why HDR is the flavor. So every major standard body is looking at it because they realize that it's going to be the next step. It's going to sell more televisions, which of course the manufacturers are very happy about, and so everyone and anyone is looking at it. We even had a European cost action, which is looking at it, trying to coordinate research around Europe just for this purpose, because it's going to happen, and let's make sure we get it right so that it is future-proof and will provide HDR for the coming 10 years at least.
No, I think that's a good point there, that when you're breaking down what is UHD, and so HDR can be thought of as one of the main components of this new UHD technology that's out there.
Right.
And I think you're right. I mean, the pixels, having 4,096 pixels or 2160, pixels is great when you're up close, but it's not the whole picture. There's more to it. And I think the dynamic range is definitely a huge part of it. You said 96 bits per pixel. There's a lot of data going back and forth here between players and displays at this point. The title of your presentation was 12 bits is simply not enough. How many bits would be enough?
Well, okay, with decent compression, we can do HDR video now on 8 bits. by using a two-stream method, which effectively you compress effectively the Chrome and the Luma roughly in as separate streams, different aggressions, and you can do that. So we can play HDR video now on mobile devices, on HDR screens, whatever. Whereas a one-stream method, which is just using a single stream, the 10 bits is definitely flavor of the month. But when you're trying to compress both Chroma and Luma into 10 bits, you run into problems. Maybe 12 bits will help, maybe 16 bits will help, but the chances of consumer electronics getting to that number of bits in the near future is less likely, and so therefore suddenly you're going to have those the haves and the have-nots, the people who have HDR because they've got 10-bit infrastructure, and the people who haven't. And we say no, you don't need 12, but you can run with 8-bit legacy infrastructure. We can deliver HDR video now to a mobile phone. If you've got an iPhone, we can play HDR video on it. You can't see it the full range, of course, because it's a low dynamic range screen, but you can actually explore the different exposures. You can tone map it to get the best image. You can change that dynamically, what we call true HDR. You've got all the HDR information at the screen, and you can choose how you want to see it. But the other problem with the spatial resolution, the 4K, is that with the 4K, when you start taking images which are wider, because you need it for the 4K, you actually end up with far more dynamic range in the scene. So 4K without HDR has also got problematic. We saw in the World Cup in Brazil, when they filmed the stands and the action happening on the field, and they looked into the stands completely overexposed because they didn't have the dynamic range. So 4K by itself is simply, when you start looking at wider scene angles, you're going to have more dynamic range, and then you're going to have problems.
Well, speaking of screens specifically, from an end user standpoint, if I'm a consumer out in the market interested in HDR, and maybe I'm in the market for a new TV right now, where are we kind of at in the adoption curve from the manufacturers? I know we've heard from Sony that they're going to have HDR support on their TVs this summer via like a firmware update. I believe Samsung is kind of in the same boat. There's been some information floating around from them about the new JS series and having HDR, but it all feels very nascent to me. And like, where are we at as far as display manufacturers coming on board with HDR and the ability to really truly support it right now?
Okay, so there's been an HDR display manufacturer for at least over 5 years called Sim2 in Italy. They acquired some of the technology from Brightside through Dolby when Brightside was acquired by Dolby back in 2007. So there's a commercial HDR display you can buy now. The latest one is 6,000 nits, so 6,000 candela per meter squared. The ones that these big companies have been claiming to be HDR are 1,000 nits. If you went to any of the demos at NAB, to see the 1,000 nits, you've got to sit in a dark room. And then you can see the difference. We had a 4,000 nit Sim2, the older version, on our stand, just in the open stand, and the difference was clear. So people claiming that they have now HDR on the screens is it's not HDR unless you're in a dark room, and it's not good to your eyes anyway to watch bright lights in a dark room, because again, it's not evolutionarily compatible. Whereas there are commercial displays. The problem with the Sim2 display, because there isn't the mass market for it yet, they're expensive by sort of TV standards. But I believe as people start to go really understand the benefits that HDR can give, so a company like Sim2 will start to sell a lot more displays. In fact, goHDR is a reseller for Sim2 displays. And when that happens, and people are going to realize that they don't want 1,000 nits and watch in a dark room, they want to watch a television in normal lighting conditions, but they still want to have the benefits. And then you need to talk about a 4,000 and more, 6,000, and then 10,000 nits. And everyone say, "Oh, that's an awful bright image." Well, okay, UK is always a bad example for this, but I'm sure in California, if you look out your window, it's a lot more than 10,000 nits, and you don't have a problem with that. Your eyes can look from inside to outside without a problem. In the UK, it's just grey, so it doesn't really matter. But so this whole idea that this image fatigue because these displays are going to be too bright. No, they're only going to be too bright if you happen to be watching them in a pitch black environment, and that's not where you watch the television, especially when you get to mobile devices where you're watching them on the go. This whole thing that 1,000 nits is an HDR screen is a myth. 1,000 nits is nothing, compared to what our eyes are used to every day.
Yeah, no, I think that's important. I know some of our listeners out there from the integration world, when they start hearing 1,000 nits and 6,000 nits, they might automatically think to, oh, what about outdoor displays that are meant to be displayed, for digital signage purposes, or jumbotrons that are like 10,000 nits. And the difference, I think, and I'll let you speak to this, Alan, but I believe the difference is, again, the dynamic range. It can be as bright as 6,000 nits, but it can also be as dim as, I'm not really sure what the floor is, but it's about the range between those two nit levels, and like an outdoor display for digital signage might be 10,000 nits, but it's not going to be able to produce much detail at lower brightnesses. And I think that's where the darkroom comes into play. Is that accurate?
I mean, dynamic range is about the simultaneous contrast. So it's a ratio between the brightest and the darkest areas. Mm-hmm. And of course, if you've got a 1,000 nit display and you've got good black levels, so contrast ratio, they divide the brightest by the darkest and end up with some infinite number because you're dividing close to zero. I mean, that makes no sense. Mm-hmm. So really, it's about the simultaneous contrast that you can see on the scene at any point in time. So yes, these outdoor displays are 10,000 nits, but their black levels may be as much as 1,000 nits. The Sim 2 display has got a peak brightness of 6,000 nits and a minimum brightness of 0.005 or something like that. So you've got this massive dynamic range, so you can see these real contrast differences. The problem, of course, is if you take a screen which got a peak luminance of 1,000 nits and a black level of 0.05, and you put it in a dark room, you can see the black levels, and so you get a great dynamic range. But the moment you put that screen into a normal ambient, even your indoor lighting environment, let alone outside, of course you don't see the black levels anymore. And so the dynamic range that the screen can actually show in normal ambient lighting condition is poor. And that's where you need the peak brightness and the darks to be able to show them in sort of standard viewing conditions.
So, Alan, am I understanding correctly that we're kind of at a point in the market right now where we almost have like a pseudo standard, and we have this concept of HDR, but there's manufacturers out there who are essentially taking liberty with that term and saying, okay, well, we have a display that, that can get up to 1,000 nits, and we're going to call it HDR to try to sell more displays. Is that kind of what's going on?
Yeah, that's certainly kind of
Go ahead.
In the MPEG committee meeting. One of the first things we managed to do, and this is from the work, the cost action that I coordinate, was to get a definition of HDR into the document. So it's not a peak luminance of 1,000 or 10,000, not at all referred to the display, because that's not future-proof at all. It's about how much light there is in the physical scene. And basically the definition of HDR is greater than 16 f-stops. That's 10 to the 16, range between the brightest and the darkest areas. So yes, people are using the term H in the same way that 4K. Your definition of 4K ranges from depending what supplier you're talking to. So HDR is certainly being used by manufacturers to sell, because it's the hot topic. So everyone thinks, oh, HDR must have that. And basically what they're doing, they're showing slightly brighter televisions, but they're showing to you in a dark room, as we saw at NAB. Every time you went to an HDR display, it was in a dark room, and that's fine. And but the moment you take it home and you turn your lights on, you're going to go, where's the brightness gone? And that's the thing. So yes, it's a buzzword that people are jumping on, and I think it's a real pity, because HDR can make a significant difference. I said the step change between color and brightness, and black and white, because not only does HDR make things different, but you also get a lot of depth perception from HDR without the need of 3D glasses, because in the real world, we use the dynamic range in the scene to get an idea of depth, where images that are further away are less saturated, and so we get natural depth from dynamic ranges in addition to contrast. So, it's important to if we're going to try and get something which is realistic, then let's stick to the real scene, not to what current display capabilities are.
Yeah. Well, I'd like to just shift gears here slightly, just for a minute. Maybe if you could speak to this, because I think it's insightful to learn a little about like how HDR content is actually being produced. And really, the concept of HDR has been around for a very long time. Kind of was given birth to in the world of still photography, where they would, take two different images at different exposures and essentially, overlay them together to get that wider dynamic range. Obviously, if you think about, I guess, the logistics of that, when you go from still to video, it's a whole different animal. And can you speak to kind of how this content is being produced nowadays, and maybe how that's evolving, from the world of like the actual production side with the cameras and the hardware and everything that's being used to produce this?
Okay, so this is the reason why that HDR imaging has been around for a long time, and HDR video is only just happening recently, and that's why we had the HDR video camera done. The big problem, the static image, you take multiple exposures, and that allows you to build up the static image, and that's perfectly fine as long as nothing moves. The moment anything moves between those exposures, you get what's called ghosting. And that's always been the problem. So how do you capture these dynamic range in the scene if you're using multiple exposures, but either the scene's moving or the camera's moving, and you get these massive ghosting effects. So the camera we had built for us had 4 sensors very closely aligned inside the camera, which allowed us to get the 20 stops. But it wasn't without its problems. But what is happening is that the camera manufacturers to date have been capturing a wider dynamic range, maybe 14 stops, but because of existing display technology, they've only been able to take off 8. And so what they do, they capture the 14, but off comes 8, maybe in some form of tone mapping. What we showed at NAB was we had an Arri Alexa camera, which is capable of 14 stops, and we took all 14 stops off without doing any tone mapping it, and we used it straight onto display. And immediately you've got a far wider dynamic range. It's not high dynamic range, not 16 f-stops yet, but certainly a lot more than people are used to seeing. And HDR video from even 14 stops on an HDR display is very impressive because it is so much more than the 8 stops that we're used to. So I think what's going to happen is that as the displays become more common, the camera manufacturers are in the interest now to suddenly keep all the data that the sensors are giving them anyway and look to develop new sensors, because the problem with multiple sensors will always be, or multiple exposure will be, ghosting. And there's something like 42 papers in the academic literature at the moment on deghosting algorithms to try and compensate for this problem. Some work well and some work less well. But the moment you're trying to do that, you're always going to have that problem. But as sensors can capture wider dynamic range until it gets to the point where it can capture 30 stops, which is a sort of the standard to aim for, then which is a lot more than human eye can see. Then it'll be a solved problem. But so it's better to look at the amount of light in a scene as what we should try and improve upon, not what a current display does, because a 1,000-nit display doesn't need a massive high dynamic range camera to capture that.
Mm-hmm.
Yeah,
interesting.
Go Jason, ahead, I've got one here that touches on the medical world, since that's kind of where I've been working for the last couple of years now. I mean, I personally think this added color information that comes along with these HDR cameras and sensors that can capture this at an optic level, on the capture side, and then it's encoded and then delivered to a display that can also accurately reproduce this color information. I mean, I think that image-based, minimally invasive procedures in the medical world can greatly benefit from this. So, Alan, I guess my question to you is the medical industry paying attention to this, and should they be?
Well, I think HDR is going to touch all aspects of imaging. It's going to bring benefits to everyone, and certainly HDR by itself doesn't give you more chroma or color. You need some sort of wide color gamut, but there's no doubt that HDR images look more colorful because you've got brighter colors. So even though they're not more saturated, they actually just look brighter. But I said the work we did before with the thoracic surgeon, where we literally filmed over the shoulder, the ability for the surgeon then and the people, the students who are watching the footage, to go in and look in all the detail. As a human eye would see. I mean, the human eye, when the surgeon's doing it, they can see all the detail inside and outside, because the human eye can do that. The human eye can see 20 stops with minimum adaptation, which is the reason why we had the target for the 20-stop machine. They can see all the detail. And of course, when you've got the camera, you've captured all that, then you can start to explore and see what's in the dark body cavity. And believe me, it was pretty gruesome stuff. So I think these things where you're able to capture information that the human eye can see and beyond. So certainly the work we're doing, rocket launches where the human eye can't look into the flume of a rocket launch. We just can't do that, but the cameras can. And even on a bright day when it's been raining, the human eye will struggle to be able to look out the car window. But of course, an HDR camera can do that. So from autonomous car vehicles and things like that, HDR can play a major role, because we can capture now more than the eye can see and deliver it what the eye wants to see or needs to see. And that's a key thing about HDR. You can shoot and then provide the detail later on, whatever way you want to look at it. If you want to look what happens in the shadows, what's happening in the bright areas, you can do that. And that's the secret. I think it's going to impact on everything. And of course, with HDR, with better sensors, then we'll look at capturing wider color gamuts. And that'll certainly make a difference. But the human eye is less, at the saturated level, we don't really see it as well as for example, dynamic range. But there's certainly, the improvement. That's what the UHD TV is all about. It's basically getting to the point where we've reached the capability of the human eye, and then theoretically we can't go beyond that.
A thought just occurred to me. If HDR really takes off and we see it develop to its full potential, are there going to be a lot of lighting professionals that are out of jobs?
Well, I think they're going to be able to. I mean, the thing is, of course, the key thing is in a lighting profession is to create a mood. Yeah. And this is one of the things that we've been looking at, exploring the idea of true HDR. If you create a mood in a film, you've no idea how someone's watching at the other end. And so you spend all this time creating this mood, and they're watching on their tablet, while wandering around outside. So again, if you capture all the range of light in the scene and you deliver it and you understand where the person is, then you can recreate the mood at at the viewer end. So I think the need for lighting is still going to be important for that sort of artistic impression. But for things like, people capturing a moment of history that happen to be there with their mobile phone. At the moment, if they film something and there's maybe it's a fire or something, you just don't see the detail because the cameras can't cope with it. The moment you've got HDR video on your mobile phone, you can suddenly capture all the detail, and you film, and afterwards you can go back, or the police or whoever goes back and says, okay, look what's happening in that shadow there, which you didn't notice at the time, but of course your camera captured. I think that's why you're going to have this really great ability to just shoot everything, and afterwards, be it the director of a film or forensic expert afterwards, can go back and look for the detail that they really want from that shot. And so, on the set, the director doesn't have to worry about, I must get the lighting ready. They can rather look at how better to do that.
Yeah, it's funny you bring that up, because I'll point this out and we'll include it in the show notes at avshoptalk.com. But there's a little like a comic on your website where there's like a newscaster standing in front of a big fire and a cameraman looking at her, presumably with an HDR camera, and you see the lighting guy in the background running away saying, "Oh, I'm not needed here." So I thought that was pretty clever.
Yeah, we actually had a lot of these cartoons. We had them done to try and, in fact, I can send you a whole range of them to try and explain people the concept. We work with wonderful cartoonist, a guy called Lance Bell, who comes to our meetings of the cost action, and he's tried to, on a number of occasions, capture what we mean and what the issues are in a cartoon, because then it's much easier to explain to people, as the need for lighting crew. I mean, and we have one of the medical surgery where the camera over the shoulder of the surgeon. I'll send you a range of them. You can have a look at them and see which one. You're welcome to use them. They're not. There's no copyright or anything associated with them.
Great.
Cool. Nate, did you have something there?
Yeah, we're happy to get your message out there. I mean, I think we believe that this technology could have a definite positive impact on the industry. So those are the types of technologies we want to talk about and make sure people know about and they're following up with. And we'll just have to see how this all pans out when it comes to the standard being written, and that's kind of up in the air at this point. And I think that's the battle that we're going to be fighting as an industry, is trying to really get this right versus trying to be the early bird that is first in, versus actually taking your time and getting the standard right, so that it is a standard and manufacturers from all over the world start adopting the same standard. That's going to be the challenge.
Yeah, and that's as an academic. That's my job to really inform people what the options are. And not in the end they'll make their own mind up. But the key thing, I think people really need to experiment with HDR more and learn a lot more about its potential and what it can do, rather than rush to sell the next television. And now, of course, there's a need for that, and that industry, that money that's made from that helps drive things forward. But I think there's a real need to look at the options, to understand the alternative, to experiment, to play with different options, different brightness of display, different images, different types of scenarios, and based on that, make a decision as to what is the best way to try and encompass as many of these as can. So otherwise, we're just going to be back here in 2 years' time saying, oh, now we've got a display which is 10,000 nits. We had one 2 years ago, 1,000 nits, and now it doesn't work anymore. And what are we going to do? And go through the whole process again. And of course, the more standards you throw at the industry, the less likely they are going to adopt them, because they just get tired of having to change every time.
Right. Well, Alan, we want to thank you again for taking the time to come on and join us. I learned a lot, and I hope people listening, took a lot away from this. And if there's anybody listening who might want to learn more about HDR, or you specifically and your company, what would be the best way for them to maybe reach out and contact you to learn more?
Well, they can go from the website, goHDR.com, or they can just email me, alan.chalmers@goHDR.com. I'm very happy to speak to people. I say what we're really looking for is people who want to try and adopt this technology and work with us to just experiment and learn more. And I think that's the more we educate people before they grasp the standard, the more informed that standard will be. And I think that's a key thing we need to do.
Yeah, absolutely. Well, we'll include those links as well in our show notes at avshoptalk.com/episode 17. Alan, we want to thank you one final time for taking the time to come on here and join us on AV Shop Talk.
My pleasure. Thank you for your interest in HDR. I think it is going to change the world, and I think we need to get it right. So I'm really glad that you guys are really interested enough to follow us up.
All right, you got it. Thanks again. Take care, Alan.
Thanks, Alan.
Cheers. Bye-bye. I'll send you those cartoons now.
All right, great.
Well, that concludes our interview with Alan Chalmers of goHDR. We're very, very excited to talk with him. It was one of those times where you realize how much you still need to learn about video, at least for me, as an integrator. by no means, just because I'm able to turn on a microphone and talk shop does not necessarily mean I'm an expert at all things audio video, but I am eager and willing to learn. And, it would be interesting to be a student in one of his classes, I think. If I could go back to school, I mean, his classroom is probably where I might want to find myself. What do you think, Jason?
Yeah, no doubt. I really enjoyed it, and I think you're exactly right. I mean, to me, it's kind of one of the things that keeps me interested in what I do, and it's one of the fun aspects of doing, audio visual or systems integration as a profession, is there's always something new to learn. And I think diving into new topics and sort of having those little, aha moments where the light turns on and you understand what you're looking at. It's fun. I enjoy that, and that's a big part of the reason why we're here doing the podcast. Right? We like to dive in and kind of explore these new topics and share that with the audience. And really appreciate Alan coming on. I had a great time chatting with him, and I certainly learned quite a bit from it.
Yeah, it was great, and we hope you enjoyed this episode. I want to thank you guys for tuning in and listening. We hope you integrators out there and audio video professionals, find this content valuable. And also, just wanted to say thank you for subscribing to the podcast, however you subscribe, and for following us on Twitter. I know there's a ton of people in the Pro AV world that are on Twitter, and we just hit like 500 followers this month, so that was kind of a big milestone for us on the Twitter account. So just wanted to thank you guys for following on Twitter. Appreciate it.
Yeah, absolutely. That hit that 500 mark, so always exciting. Like you said, there's a lot of people out there doing this, and Twitter is a great place to connect with other industry professionals, and we really appreciate people connecting with us. It's been a lot of fun doing the show. This episode was no exception, and we look forward to sharing another one with everybody next month. Once again, we'll be publishing on the first of every month, so mark that on your calendar, and we'll connect with you again a month from now.
Yeah, I wanted to also give a quick shout out to one of our Twitter followers here, at @S_Smizzle. He wrote back, and he said he loved the show, and of course we always love getting feedback like that. Now, I don't know this Mr. Smizzle character. I'm assuming that's a nickname, but just in case that's not, thank you, Mr. Smizzle from NCC_com out in the I believe in the DC area. Thanks for tuning into the show. We really appreciate it, and that's why we do the show, for other people that find value out of it. So really appreciate the feedback.
Yeah, absolutely. And if you're listening and you enjoy the show, definitely connect with us on Twitter at AV Shop Talk. You can stop by the website, avshoptalk.com, leave us a comment. If you have any, suggestions for future episodes, we're always receptive to that. We read all those comments, all the emails that come in. We definitely appreciate it. And, once again, just plain old word of mouth. If you enjoy the show, you find value in it, find it entertaining, and some friends or, coworkers that might be interested in it too, just feel free to let them know. That's kind of what helps us get the word out, and we would appreciate it. But thank you so much for tuning into this episode. We hope you enjoyed it. And once again, we look forward to connecting with you next month, and we will talk shop with you again on the next episode of AV Shop Talk.
AV Shop Talk podcast is produced independently by Jason Griffin and myself, Nate Schneider. Musical contributions have been provided by Colin Owens. Voiceover contributions have been provided by John Perry. For more information about the episode you just heard, visit avshoptalk.com/episode 17.